In this lesson, we are going to be evaluating and graphing piecewise functions. A piecewise function is part of a line or segment. That's why it's called a piece. It's a part. A step function are horizontal segments. That look like a set of stairs or steps. The first thing that we're going to do is to evaluate a piecewise function. Now notice a piecewise function, f of x, remember that always can mean y, so y equals mx plus b, and it shows that there's two different parts. The top part is if x is less than or equal to 3, and the bottom part is if x is greater than 3. So we're going to take a look at the first value if f of x is 0. That means x is equal to 0. That would work in our top part of our function because it says for values of x being less than or equal to 3. So what we simply do is take the expression 3x plus 2 and we substitute the 0 in for x. 3 times 0 is 0 plus 2 is 2. That is evaluating or calculating for our piecewise function. Next one, f of x is 3. So f of 3 means we're going to take our 3 and plug it in for x. This again will go into the top part of the function because it says x is less than or equal to 3. So we're going to plug the 3 in. 3 times 3 is 9 plus 2 equals 11. I've evaluated that part of the piecewise function. Next, it says that x is equal to 6. So since that is the case, we want to take a look at the bottom because our restriction or parameter says that x has to be greater than 3. So x minus 1, we're simply going to substitute 6 in for the x and calculate, and we've evaluated that part of the piecewise function to be 5. After evaluating, we want to graph piecewise functions. Remember, we're simply only going to graph part of a line. That's what we're doing. A piecewise function is part. So I'm going to graph only the top part first. Y equals 3x minus 4. So to graph, I'm going to graph my y-intercept at negative 4, and my slope is up 3 and over 1, up 3 and over 1, up 3 and over 1, and so forth. This time, it says, though, the part that we want is anywhere where x is greater than 2. So find out where x is 2, which is right here. But since it says greater than 2, that's going to be an open circle. So we're going to draw an open circle at 2. And we want to go then to the right because it's greater than. So we're going to make our arrow go to the right. And anything to the left we're going to erase because we don't want that part. In the second example, which is y then equals negative x plus 1, our second example, our y-intercept is at 1, and we're going down 1 and over 1, down 1 and over 1. However, this time it says that we want anything that's less than or equal to 2. Less than or equal to would be a filled or a closed circle. So where x is 2, we just go backwards one more, and we know that we're right here and right here. So we're going to put a filled in circle and we're going to go everything to the left. And also we would know then nothing to the right would work. So that would also work if it had said greater than or equal to. And this would also work if it would be less than. Anything without the equal sign is an open circle. Anything with an equal sign is a closed circle. Let's take a look at another one. So in this one, y equals mx plus b would be y equals x plus 5. So we're going to put our y-intercept at 5, and we're going up 1 over 1, up 1 over 1. But this time, the piece says that we want to find where x is equal to 3. So find the x value being 3, which is right here. And it's less than or equal to, so it's a filled in circle, and it's less than, so it's everything to the left. So from 3 to the right, we will erase because we don't want anything to go to the right. The second part of the function, f of x is equal to 2x minus 1, or y equals mx plus b, we can start at negative 1 and go up 2 and over 1 for our slope. This time it says x is greater than 3. So we find out where x is 3, and this time we want an open circle at 3, and we want to go to the right because it's greater. So this time we'll erase everything to the left. We don't want anything smaller. In our next example, f of x equals 2, that means just y equals 2. So when we practice graphing, y being 2, we know that that's going to be a horizontal line because x is not given to us, meaning it's infinite. But our parameters or our restrictions say that x is less than 1. So where x is 1, we want an open circle at 1, and less than means to the left, which means we're going to erase everything to the right, and this is just going to be a horizontal ray pointing in one direction. The next part of the piecewise function, y equals negative 1/3 x plus 5. So we have a y-intercept of 5, and it's going down 1 and over 3, down 1 over 3, down 1 and over 3. If we connect those together, we know that this time we're going to go to the right because it says greater than or equal to 1. So where it crosses the x value being at 1, we know we want a filled in circle because it is greater than or equal to. We're going to erase everything to the left. We know that we're going to the right. In the next example, we know that we have a step function. And not only because it tells us in the directions, but because each of these is a single value, showing that these are going to be horizontal lines. So we have a horizontal line at y equals 1. But it tells us these parameters or restrictions, that we're going to have a filled in circle at negative 4 for the x value. And we're going to have an open circle at negative 2 for the x value. And we're going to shade in between because our x value is in between the negative 4 and the negative 2. In the next example, we are going to have our value being at, our y value is at 2, which is along here. This time we have a solid filled in circle at negative 2, and then we have an open circle at 0. And then we will shade in between the two of those values because our x is right in between the two of them. In our next example, we are at -3 for y, or excuse me, at 3 for y. So we're right here. This time, they say that 0 is a filled-in circle because it's equal to, and the value of x being 2 is an open circle, and because the x is in the middle of the two of them, we're going to shade in the middle, or put our line segment in the middle. Our last part of our stepwise function in this case is where y is at 4, which is right along here. This time our parameters say that x is equal to 2, but it is less than 4. So we're going to put an open circle at 4. We're going to shade in between the 2 and the 4 because our x value is between the 2, and we'll erase the rest. This is an example of the stepwise function because it looks like a set of stairs or steps. It is horizontal line segments. Please try student problem 1, 2, and 3 and submit.